Hi everyone, today we are making silver tetrafluoroborate, the silver salt of tetrafluoroboric acid, a very useful non-nucleophilic mononegatively charged inorganic anion used in both organic and inorganic chemistry applications. I previously made the potassium salt, but now I am making the silver salt because it's a good dehalogenation reagent. Having as a counterion silver 1 means that it will form a really insoluble silver halogenide, like silver chloride, that will precipitate, driving the reaction forward. The first step in this synthesis is making silver carbonate. So for this, we'll weigh out 5.03 grams of silver nitrate and 1.62 grams of sodium carbonate. Beware that silver nitrate and silver carbonate are corrosive, and silver nitrate is also an oxidizer. The carbonate was dissolved in around 10 milliliters of distilled water, while to the silver nitrate was added 2 milliliters. The solutions were stirred with a magnetic stirrer until both turned clear. Both solutions were then quickly filtered through cotton, and then the silver nitrate was added to the sodium carbonate solution to obtain a white-yellowish precipitate of silver carbonate. This precipitate was then filtered through a Gooch filter, and the solid residue was removed from the filter. This is a classic double displacement reaction. Silver and carbonate ions combine to form the least soluble compound, precipitating from the reaction mixture. While silver nitrate and sodium carbonate are two pretty soluble salts, the solubility constant of silver carbonate is only 6.15 times 10 to the power of minus 12. Thus, being this low, it instantly precipitates. Now comes the dangerous part. So just as a reminder and disclaimer, while silver nitrate, as previously stated, is only somewhat irritating, but also stains a lot the skin, now we're dealing with 40% HF and tetrafluoroboric acid. So double HF resistant gloves, goggles, and a respirator with proper filter were used. Just as an informative note, HF burns are highly dangerous, and depending on the amount and concentration of the HF, those can be deadly. So using calcium gluconate is only a temporary measure, and immediate medical attention shall be taken. One last thing before we move on. HF burns are white with a red halo around it, while silver stains begin as white-gray, later turning black. When working with both, it is imperative to avoid any contact with both substances to not mistake one reagent burn with another. Moving on, in a polyethylene beaker, we measure out 5.22 milliliters of 40% aqueous hydrofluoric acid. In another beaker, we weigh out 1.85 grams of boric acid. We then add a stir bar to the HF and we start stirring, while really slowly adding the boric acid, as the addition is highly exothermic. In this reaction, HF reacts with boric acid to make tetrafluoroboric acid. It's interesting to note how the geometry changes from trigonal planar to tetrahedral. Boron has 2 electrons in the 2s and 1 in the 2p atomic orbitals. If we look from a hybridization point of view, with the 2s and the 2p orbitals, 3 sp2 hybrid orbitals are formed, which bond with the 3 OH groups, which in this case are acidic proton donating group, and a p orbital remains free. This is why the compound is planar and can accept another pair of electrons to form tetrahedral complexes. When the tetrahedral complex is formed, the hybridization changes from sp2 to sp3, and geometry goes from trigonal planar to tetrahedral. After the addition is completed, the reaction mixture is left to stir for some time, and then it is poured into a 50 ml round bottom flask. A stir bar is added, and under vigorous stirring, the wet silver carbonate is added in small chunks to prevent excessive CO2 bubbling that could lead to a very corrosive geyser phenomena. This third reaction is a simple acid-base reaction where tetrafluoroboric acid and silver carbonate react to make silver tetrafluoroborate, carbon dioxide and water. Unfortunately, the salt is highly soluble in water, but as no other ions should be present in solution, we can just distill off the water and hopefully get our silver tetrafluoroborate as a dry powder. To be honest, I already did this synthesis one time, and the plan was to add halide for the tetrafluoroborate to absorb on it, but the halide was pretty shit quality, and what came out after distillation was and remained even after days in the dehydrator really wet. So this time I just distilled the water under reduced pressure with a short path distillation setup. The decomposition temperature of silver tetrafluoroborate is 200 degrees Celsius, so we should be pretty safe even at atmospheric pressure. After distillation, a brown, damp solid was obtained, weighing wet 4.90 grams, representing a percentage yield of 83.7%. But this is still kinda wet, as I didn't want to heat it too much, so I'll have it to be dried before using it for my next reactions.